are now back. It looks like our Ortho Agisoft is still processing through the cloud right now, so we're not going to be able to review those results. So instead, we're just going to dive in to our classification. So for those of you that may be using the AI Ground tool, you can do your smoothing, your noise removal, and ground classification all at the same time. So that's what I'm actually going to do now, is I'm going to submit that off to the cloud for processing with all of those in mind. But you'll see here, when I clicked on it, it says that that auto AI license is needed. That's because it is assigned to your email. It is not associated to the organization. So it's telling me right now, I do not have this assigned to my email. So I'm going to click yes, please take me to the portal. Only your admins can assign this to you. So you have to be an admin of your organization. Which I happen to be. So I'm going to go into my admins. I'm going to go down here and find that auto AI license. So here it is at the bottom. And this does apply to any cloud licenses that you may have. Click add here, and I'm going to find my email. So let's see. Here I am. So I'm going to add that to me. That way it can be processed. Does anyone want me to add them while I'm here? Also, if a bunch of us, and this is random, you can keep it out of the video, but if a bunch of us submit an AI job off to the same time, it will take longer to process. So unless you really want it, don't send it off to the thing. Huh? Okay. Yeah. Yeah, it kind of puts them in a queue, so then they run like that. Anyways, well, I assigned it to myself. I click apply. It will apply those changes. And you can now see that I have more users here. I'm now going to go here back into LP360. I'm going to click this icon again, the AI Ground Classifier on the Ground Classification tab, and I'm now able to start the job. So I'm going to select my strip align debias layer. So that's the one where I ran strip align, and then I debiased it so it would be more accurate to my control points. I'm going to specify a name. So I'm going to call it Day 2, AI Ground, December, just like that. And I will submit it off. Now this little pop-up you see here is only for internal users. You will not see this when you are processing in your own accounts. So I'm just going to click OK there to bypass. And then once it has successfully submitted to the job manager and it's uploading to the cloud, you will get this confirmation page. So I can open my job manager. And it looks like my MFE just finished. So that's my, my Ortho cloud job. So I'm actually going to go ahead and complete that one. So we can look at that, and our AI is already executing. So here we go, complete this job. My nose is itchy. All right, so it has successfully added. I'll click OK here. And we can actually see it adds it to the top of my table of contents. So I'm actually going to toggle between this one and our other Ortho that we generated earlier, so you can really see the difference between these two. So right now you can see my little picnic table down here, and you can see my little barricades. But as soon as I switch over to my RGB, you can really see the difference in that quality of Ortho. Same with if I go find my control points. So I have a bunch of them right next to each other up in this front parking lot. I'm going to come over right here. We can actually see our accuracy star. That's what we're looking at here. And then all these targets. So this is my Agisoft Ortho mapping. And this is my regular Ortho mapping tool. So you can really see the contrast between those. So that's why it's very important to know which one you are wanting to process so you can get the correct licensing. These are GeoTIFFs. So if I go into my open location and explore, it'll actually take me there, and it's going to be a TIFF format. Okay. All right, so now that we've done that, we are now ready to begin our classification steps. So remember, we want to remove our noise. Since we are smoothing in the AI job, we're also going to smooth here, and then we'll actually get into that classification. So before I get there, I actually want to clean up my table of contents. There's just a lot going on here. So we're actually going to limit this to only our orthos and our final LAS layer. So the way I'm going to do that is I'm going to go to my project ribbon, and I'm looking for the manager button. Okay, this will open the project manager. You're then able to filter down what it is you want to see. So you can either click on one of the predefined options. So this will show all my LAS layers, my rasters, my features, but I actually want to make a custom one. So I'm going to click build here, build, and I'm going to click this add button. So I'm going to call it LAS and Ortho. You can call it whatever you like. You can even give it a description. So just so I can keep all of my records straight, I'm actually going to call it day 2, I can spell, day 2 in person. Okay, just like that. Now you'll see there's a couple of different check marks here. So V is for visible, M is for member. Member means that's what's going to be showing up over here. So I want to turn everything off. So I'm going to select all of these. You'll see it highlights all of them. Turn that off. So I only had to click once and it turned them all off at the same time. And now, because it's a lot to look at here, to make it a little easier on myself, I can actually go find the layer types to filter by those. So I can see all my LAS grouped together, my rasters, my points, all that good stuff. So I'm going to find my debias layer. So it's this one. I'm going to check it as a member. And now I'm going to go find my rasters, my 2 orthos. So here's one. That's going to be my high resolution ortho. Here's the other. And I could also include these surface precision if I want to, but I'm just going to leave it as those 3. Okay. Now to actually get them to display, I'm going to click this refresh button here. And it will repopulate my table of contents. Once I am satisfied with this, I can then choose the use mode. It will only show me what it is I already have in my table of contents, and I'm free to close this out. Did everyone follow what I just did? You don't have to do it, it's entirely optional, but I do think it's very handy before you're starting to go into a lot of classification and things like that, because it's going to make it a lot easier to follow along with your table of contents. Okay. Now that this is done, we are going to start with our point cloud tasks. So that's going to be the point tasks ribbon up here at the top. For those of you that might be using an older version of software, your tasks may still be located at the bottom here in the table of contents for you to access. So I will reference both of these for those of you using our newer version of software and our older version of software. So what I'm going to do is now open up my PCT manager to get my first task. So for those of you in the older version, you'll look right here for this gear icon. For those of you in the newer version, you're going to look for PCT manager up on the ribbon. Both of these will activate the same dialog. Okay. Once you have this open, I actually like to sort by my name, so it'll filter it all in order. And I'm going to look for the task labeled 002-TrueView-Smooth Point Cloud. 002-TrueView-Smooth Point Cloud. You can double click on that and it will automatically open up the settings. For our newer versions, it will be in its own standalone dialog. For those in the older version, it will be listed over here. Okay. Now what this is going to do is it's going to compress those noisy areas around the mean of the data. It is not going to change our data in any way, shape, or form. It is also going to create a new LAS layer. Okay. I could go ahead and specify this name here, but for those of you on an older version, it doesn't let you enter in this name. So I'm going to leave it as the default just so that everyone gets the same result. Okay. So I'm not going to change any settings here. I'm just going to close this out and I'm going to run this by my active LAS layer. Your active layer should be the stripalign_debias layer. Okay. Like I said, I'm going to run by active layer here. It will ask to confirm that this is what you want to do. So if you stop and read here, you will actually see the name of the task that you have selected. So I can see right here, and it will actually list out the active LAS layer you have displayed. Now, I actually have caught myself before where I accidentally selected the wrong active LAS layer, and I was actually able to catch myself before submitting this task so that I didn't run it unnecessarily, so I could make sure the right one was selected. In this case, the answer is yes, and it will begin processing. All right, it looks like we are now done smoothing. So I'm actually going to draw me a profile like we did before, so we can actually compare those results and see how this impacted our data. So I'm going to come over here towards the middle of my data set, but first I do want to change this name here. Okay. So we're going to select our LAS layer 1. We're going to click the name, and this time it's going to be strip align, debias, there we are, smooth. So again, that's so I can identify everything that was done to this particular LAS layer, even if I come back 3 months from now, okay? So I'm now going to draw a profile across my entire area, but again, I'm going to keep it very thin. So I'm going to use that 0.3 option again, because I want to be able to see the definition of everything. And now I'm going to zoom into different areas so we can actually review the results. So right now I'm looking at the debias layer. The first location we're going to look at is the top of our roof. So I'm going to zoom in here on our roof. Here's our peak. And now I'm going to toggle over to that smooth option, so you can really see that difference there. So just to do that again, I'm going to switch back and forth. See, it gets a lot more fuzzy and then a lot more precise. Okay. And remember, this is not removing anything. This is compressing it around the statistical mean of the data. Okay. Now let's go check out another location. Let's say we want to look underneath these trees here. So we've got a bunch of trees in our backyard right here. So this is our ground surface underneath our vegetation. So this is our smooth point cloud, and we're going to switch back over to that other, and you can kind of see how it spaces out just a little bit. You may also notice these little sporadic points up here, okay? Those are likely low-lying vegetation. So when I go to smooth, it will take some of those points and compress it into the ground or into the upper features, okay? But in areas like this where it's mostly trees, you're not going to experience that issue quite as much as if you're looking somewhere with a grassy bottom, okay? Now, I don't think we really get out into our ag field all that much behind our office. Let's see if we have anywhere that we may have gotten it just to compare these results. So I think there's a little bit right here that I'm trying to get to. As you can see, it can take a little bit to scroll through, but that's okay. It may be a little too sparse for us to actually see it. So smoothed. Yeah, it's a little too sparse for us to be able to tell. That's okay. But you can really see the difference, especially when you're looking along those planar surfaces. So here's just another of our ramp back there. So this is our loading dock. This is the unsmoothed data, and this is our smoothed. It really compresses those points together. Okay, so this will be a much better point cloud for further assessments and things like that. Okay. Our next step is to remove our noise, but first let's see if we can identify where our noise lies. So I'm actually going to go into the immersive viewer here. The immersive viewer, it's going to look like a window with a little guy in it. And off the bat, you can see there's a bunch of red points up here and a bunch of blue. Since we're being colorized by elevation, that lets us know it's way above our surface and way below our surface. So if I actually right click and kind of pan that up, you can actually really see those number of noise points there. Okay, so these are all the things we would want to remove. Now there's a couple different ways to do this. So one, if I caught these back when I was still geocoding, I could have rerun geocoding with my clip range in effect, and that could have helped clip some of this out so we wouldn't have quite as much to deal with. Since we've already made it this far into our processing, we can't really use that option. So now we're either going to use our low isolated noise filter, so our PCT type, or that Outliers classifier. I personally prefer the Outlier classifier because it's a more robust algorithm, and it has more input parameters. Okay. So now I'm going to go to my classification tab and look for my outliers tool. Okay. Looking for outliers. Now this one I am going to run on my smooth data set because I no longer care about this other one. I want only the smooth. You can choose either one of these or run both. Isolated are going to look for those points that are far away from everything, so they're actually going to use a search radius, whereas the morphological points are going to look for things that don't seem to mimic the pattern around them. So you'll look for stuff inside of vegetation and things like that. So I am going to choose to use both of these. If you already had classified points, so if you classified your building roofs or things of that nature and you didn't want this algorithm to touch them, you could go ahead and turn them off in that point filter. But for now, I'm going to leave that be. I'm going to estimate my point density. It'll do that for me. So this is the point density of my point cloud on average. So your density will vary depending on your terrain. Vertical objects will actually increase it. Scan angles will increase it, things like that. So for my search radius, the smaller this is, the longer it will take to run, versus the bigger it is, the less time, because it's only going to look for points that are way away from everything else. So I'm just going to use about 2 meters because I don't really want any of the isolated points that are near my surface. I could decrease that if I saw there was a bunch of cars driving through, because those will be considered noise points as well. And you could also change your cluster size. So I might change it down to like 2 or something like that. Okay. Since it is still going to be looking for those morphological points, it doesn't use this search radius. That's actually going to seek for abnormal patterns through different objects. So if I wanted to test these parameters to see if they worked for me, I could run them by a small area. But in this case, I want to see how it performs across the whole one. So I'm just going to do by active layer. Now, as mentioned, this can take a little bit of time to run. So especially if you have a large data set, you may want to use one of these smaller execution methods so it doesn't lock up your computer. All right, it looks like it has successfully executed. So we're now going to take a look at the number of points that it's classified, and we're going to look at the classification itself to see where it did that. So to see the number of points, I'm going to go into my filter icon here. This is known as the live view filter. And you'll see all of these points are in red. That just means they are not the full amount of points that you're looking at. It's more than likely just the number shown here, which is not 100%. It's not even 40% of our point cloud. So I'm going to click scan. If you have a very large point cloud, this can take some time, so you may not want to do that. But for example's sake, I did want to see the numbers. So once they've turned black, that means they are up to date. So this is the actual number of points we have. And we have over 3,000, almost 4,000 noise points. And we have a little under 300 for the morphological. So it did sort them into 2 different categories. Now to display these and actually see where they went, we're going to go back into our immersive viewer. But this time we want to view by classification, and we're going to see what it did. So you can actually see all that purple down here. We got some purple and pink at the top. So to make this a little easier for everyone to look at, I'm actually going to change that purple color. So I'm going to do that by going into my live view filter. My low noise is the purple, so I'm going to make it like a yellow color, something that'll really stand out to you guys. So I'm going to do yellow. Minimize. Let's make this big again. So now you can actually see, it looks like it grabbed almost all of those points that were off by themselves. Okay. You can see it still found some of those morphological ones, so that's along those scan lines. We can also see there's some over here in the canopy, but it mostly stuck to things that were far away from everything else, which is what we want it to do. So in this case, this one did a very good job. I am satisfied with these results. I am now safe to move on to my ground classification. Does anyone have any questions on what I just did? All right. So for our next steps, we're going to move into our next set of PCTs. So we're going to go back to our point tasks ribbon at the top. For our users with the older versions, you're going to go down here to your point tasks ribbon. Point cloud tasks at the bottom of the table of contents. We're going to open our PCT manager, which can be done using either one of these buttons, depending on your version. sort by name, and I want you to find the task labeled 004-TrueView-Ground Classification Create Seed Surface. Again, that is the 004-TrueView-Ground Classification Create Seed Surface. This is a classify by statistic type task. Now again, I'm going to double click on this so I can actually talk us through some of the parameters, and we're going to discuss how you might modify this cell size depending on your project area. Okay, so I'm just going to drag this over here. I'm going to zoom in on my tasks here, or I'm going to zoom in on my last data set here. We're going to change this to a 10. And I want you to take note of our two buildings here, okay? My cell size is set to 10. So that means it's going to break this up into a grid of 10 meters by 10 meters, okay? Inside each of those, it will classify a single minimum or lowest last return. The reason I know it's looking for the last return is I want you to take note of these little icons around the input points filter. That means there is a filter in place, and we're going to take a look at that. Okay, so right now on my classification tab, you'll see it has a yellow icon. That means there is a filter, and it's only looking at our created never classified group and our unclassified group, okay? Additionally, if we look on our returns tab, again, there is a yellow icon, meaning there is a filter in place, and it is looking for those last returns. What this means is not only will it be looking at our minimum or lowest last return, it will also ignore any additional classification we have done up until this point. So if we did any manual classification, or for example, our noise points will not be considered for this classification, which is what we want to see. All right. For our cell size, this is something that you can actually estimate using the measure tool. So for example, I have one building here. If I measure from one side to the other, that is about 8 meters. So that means for this particular building, this cell size is big enough to fall off the side and actually get a point on the ground itself, not on top of the roof. However, if we look over here to our other building, okay, this one is going to be much larger than that, right? So we're going to go from one side to the other, roughly. That's going to be almost 30 meters. So that means on this cross section here, we're going to have at least 3 or more cells that fall directly on top of the building. We're going to have points we need to remove. But for the sake of this exercise, I'm going to leave this setting as is. But if you notice that you did have buildings that were larger than your cell size, you probably want to increase it to try and keep from having to do as much cleanup. But since we only have one building, it's not so much of a problem. If you have several buildings, it can take a lot longer to clean up. Okay. All right. So our destination class is going to be our ground, because that's where we want it to go. And there is an additional option down here to actually generate that shape file of the grid that it's going to be using. Now, for you guys at home, you may not necessarily need this, but for example's sake, I am going to turn it on so you can actually see what that looks like. So in this little ellipse here, clicking this little 3 dots, I do want to talk about the output. Oh, looks like it didn't give me the output like it's supposed to. That's okay. We're going to leave it as is. Oh, it's because it's reading both of these. Go away. All right, we're just going to trust the process. So let me put this back on view. All right, so I did enable this for our purposes. I do already have an output location down here. I'm just going to click OK. It should apply those settings. Remember, if you are using the tasks down here, so you're using the older version, to set that output location, again, you can just click the 3 dots or the ellipse. And our output path here, you may notice that it looks a little funny. That is because it is using what's called the project path variable. Okay, so that means if I hover over this, it will actually read down any project that I currently have open, and it will create this inside of that project folder. Okay, if this was blank, so if I wiped this out and it was completely blank, to auto-populate that variable, I can come to the right-hand side, look for this button right here, and it will plug it in. You'll then, after the little greater than symbol, you'll do a backslash, and you'll type in whatever it is you want the shapefile to be named. You can also say, like if you wanted to create a folder for it, you could say ground grid. And again, this is for example purposes. You do not have to do this, but ground grid, backslash again, seed grid. And now it will not only create a new shapefile, it will create a folder to put that shapefile in. Okay? And because I have it set up in this fashion, it will create this same structure in every single project I execute this in. Okay? And this applies to any PCT and LP360. If you have the ability to put in an output location, I strongly recommend that you use this versus specifying that output path, because then you'll have to change it in every single project, versus if you do this, you never have to change it again. Okay? All right. So I'm going to apply my changes. That does need to happen. And now I'm going to click By Active Layer. Okay? By Active Layer. I do want to make a quick note that I'm about to execute the first step in actual ground classification here. If you notice, I have this little green flag going. My AI job's already done. So that's how much time it would be saving you if you do that. So anyways, we are now going to do the seed surface. So it's asking me if I do want to run this. In this case, the answer is yes. And it will execute. All right, so that didn't take very long to run. So I'm going to click OK here. And I want you to take note of all the boxes that only fall on top of my roof. Okay, that's the number of points I have to at least go in and manually remove that I could have avoided if I increased the cell size. Okay, so a very quick way that you can remove things like this is you can actually draw a profile. Oops, trying to do something odd here. Let me restart. So I'm going to draw a profile from one side to the other of my building, and I'm going to make this as wide as my building is, to the best of my ability. I'm going to change this to classification. And you may look at this and think, oh, there are no classified points in this. That is because our ground points are being basically swallowed up by the surrounding points. They're being overshadowed. So there's a very easy way to change this display to make it where we can actually see them. And the way we're going to do that is by creating a new filter. So I'm going to go into my live view filter, this little yellow icon. I'm going to change my point size to L, use legend. All right. And now I'm going to double click on my ground here. And I'm going to change this to a size that's much larger than the rest. So I'm going to change this to 4. Okay. Once I do that, and I move this to the side, you can now see all of those points standing out. Okay. That's because we made them bigger than the surrounding points so that they can actually stand out to us. Okay. If I wanted to save this as a filter that I could just use for my drop-down, you can just click this Save button. Give it a name, whatever you would like. You can call it large points or large ground points. And click OK, and you will now have a new filter that you can do in the drop-down. I'm actually going to click Cancel because I already have one. As you can see, I have many. No. So I do have these large points that stand out. Okay. Now I want to very quickly wipe all of these out in one go. I don't want to have to go through and manually select every single one of them. So a very easy way to do that is I'm going to hover over these tools and I'm looking for the one labeled Classify Points Above a Line. Okay, so that's going to be the first one right here, Classify Points Above a Line. Okay. It will give you helpful tips anytime you use a new classification tool. So I highly recommend whenever you're using one for the first time, you stop and read these dialogues so that you know exactly all the ways that you can execute this. Okay. So I'm going to click OK. I'm going to set my destination class to unclassify because I want to remove those from this group. And then I'm going to click on one side of my building, staying above my ground surface, and I'm actually going to drag it all the way across to the other side. All the points highlighted in white are the ones selected for classification. Once that's done, I'm going to hit the space bar, and it will apply that correction. So now I'm just going to do a couple more reviews now that this has been done. So I'm just going to close out my profile view, and I actually want to click this button to view my entire point cloud. So I'm going to click my little icon here. You'll see we also have a bunch of other stuff going on. I can actually turn these off. I don't need the orthos right now. And I want to look at where some of these other grids fall. So you'll notice there's another building back here with a whole bunch of boxes right on top of it. So that's another one where we're going to have a lot of those points on top of the roof that we don't want. But we don't have to just use our profile view to handle these. So what I'm going to do instead is I'm going to change my filter to ground system, ground parentheses system. Okay. I'm also going to change this to classification just because it's a little easier for me to see. And I'm going to turn off that grid. But before I do anything else, I want you to notice I am not viewing 100% of the points. So while I'm viewing only my seed surface, only my existing ground, I'm going to click this button right here to force 100%. It will give you a little pop-up about what this is doing. So if you're viewing a large area with a lot of data, this will not work. But we're only viewing a small portion of them. Okay. I want you to take note of this weird angular shape up here at the top. This is where we are getting that building in our point cloud. So instead of doing my profile view like I did a moment ago, I can actually go to my ground classification, do my cleanup, manual, and remove points. This will allow you to draw a polygon. So it's just giving me a bunch of helpful tips. Like I said, when you're not in training, I do recommend that you stop and read those. But this will allow you to go and just draw a polygon around anything that is misclassified, and it will be removed. So I'm going to go draw around these weird rectangles here. So this is likely that building. Okay, just like this. I'm just going to try and draw around these funky shapes. And as soon as I have selected all of these, I'm going to click spacebar. And it will remove those. Now where it looks like it kind of peaks down a little bit, this could be where we possibly have a noise point. If you wanted to do another type of inspection, you can actually draw a 3D window around this box. Change to a 10, force 100%. And we can kind of draw this to the side a little bit, and you can see if that's below your surface or not. Now, since it's only just a teeny tiny bit below, I'm going to leave it alone, and we're going to see how it performs in our next steps to see if that's either a true ground point or if it's some very shallow low noise. Okay. So I'm just going to click close on my cleanup. And I'm now ready to perform my next ground classification step. Now to do that, I'm going to go back to my point tasks ribbon at the top. Spacebar. And it should remove those points. All right. So now that we're back on our point tasks ribbon up here, remember if you are using that older version, you're going to be down here at the bottom. And we're going to open up the PCT manager. Okay. The task we're searching for this time is 005-TrueView-ground classification perform iterations. Again, that is 005-TrueView-ground classification perform iterations. Okay. I'm going to select that and click OK. We're going to open up these active settings. And again, we're going to do a quick little review of these. All right. So remember, it's still going to be filtering just like it was with our previous PCT. So we're only looking at the never classified group and the unclassified group. Okay. Additionally, we are only looking at last returns. Under our seed point selection, let me get this up close. Okay. Under our seed point selection, it is going to be using existing ground points. This is where our seed points come in handy. This is where we're actually using them. The seed sample distance is actually the grid size that we used previously. So in that case, it was 10, so I'm going to leave this one as 10. Now, here are those two parameters that you would adjust based on the terrain of your unique area. Now, a rule of thumb for these is if you have a very large variation in elevation, you have a lot of turbulent hills going up and down, rolling hills, however you want to refer to that as, you would increase that angle, decrease the distance, okay? If you have a more flat terrain, a lot more level, you can increase your distance and decrease your angle, okay? For demonstration purposes, I am going to draw a quick picture of why that is the case, just because I know sometimes it can be a little confusing, and I also want to illustrate it for my other technicians. You're welcome to clip it from the video, but that's totally up to you guys. Okay, so the way this particular task works is you are looking out from your seed point. So let's say this is my seed point here, right? And I have another one over here. Now, for example's sake, we're going to say we have a rolling hill. So it's going up like this, down, and back up through this one, okay? If I'm looking out from this point, and I'm looking at a far distance, I put in a large number there. I'm going to look out here, right? And let's say I have a narrow angle. It's not going to grab any of my points in this area. There are none. I would need a much bigger angle, and I would need a shorter distance to climb up this, okay? The exact opposite is if you have somewhere very flat. So if I'm going from one point to another, but this time it goes straight across like this, I can increase my distance quite a lot because I can still reach farther out to go grab points. I'll still be getting them in here. And I can decrease my angle to keep it towards the ground. So if I had like trees, some grass, things like that, I wouldn't really want those picked up, which is why I would decrease that angle. Does that make sense? Okay. And I can re-demonstrate that at any time. All right, so now with that in mind, we are going to try to use the default settings here before we run it over our entire area. Okay, so we want to test these out. So I'm going to leave my angle at 2.5 and I'm going to leave my distance at 0.3. Okay, now the way I'm going to test this is I'm going to change this back to my all points. And I'm going to zoom into a random area of my point cloud. So I'm going to go into this parking lot. There's a slope here and there's some vegetation. So I'm going to test it on this whole area. So I'm going to zoom in here. Pan around. So I'll have a little bit of variation. And I'm going to execute by a polygon. Okay? Because like I said, I'm going to test these out to see if they work. So I'm going to grab around here on my vegetation. I'm going to grab up here onto my road. I'm going to grab around this slope here and the remaining parking lot. Okay. Once I'm ready and I've selected what I want, I'm going to double click and you may see this pop up here. Now again, the yellow and blue icons mean stop and read me. Now what this one is telling me right now is that I have selected over 500,000 points. Okay. That is not a problem. It's just letting me know that I cannot do the undo classification button. I would have to do a basic filter if I wanted to undo these. That's okay. I'm going to click yes to proceed. You will see it running down in the bottom left-hand corner if you execute by one of these options. As you can see, this can take some amount of time to run, which is why you would want to test out these parameters versus running them over your entire area first, because if they don't work, You don't want it to eat up a lot of your processing time, right? Okay, so now it looks like we are done. So we're going to inspect these results and see how they did. So I'm actually going to change this back to my ground system only. And we're going to see what this looks like. Okay. So first off, if I zoom up under my forest here, my canopy, it does look like it's doing pretty good, but I can actually see where it picked up some patches of probably vegetation in this little area, right? I can also see that it didn't do great around my slope. So where it had those steep changes in elevation, it wasn't able to get those. And it does look like it got the footprint of my car here. That's okay, that's very easy to remove. But it does look like we have a weird little shape right here, okay? So I wanna see what's going on with this shape. I'm gonna draw me a little 3D box around that. And we're gonna look down on this. So it looks like there's something going on underneath the surface. So to check if that's actually part of the surface, I'm gonna change back to my all points to see if it starts to fill in. So that does look like it's some kind of ditch, so that's okay. So I'm okay leaving that there. But if I saw that this doesn't look like a ditch, it just looks like a few stray points below the surface, I would wanna remove those. Does that make sense? All right. Now it looks like this did a pretty good job getting our points. It didn't crawl up onto my roof. I could very easily go and inspect those other spots as well. But for now, we're just going to stick with the results that we have. Now, since I think that this did do a pretty decent job, I can now run this over my entire point cloud, or I could go in, modify those settings, and then try it again to see if I get better results. For the sake of time and for our exercise, because we still need to get into our cleanup tools, we need to compare it with our AI Ground, and we need to do deliverables. I'm just going to go ahead and run this over my entire point cloud. Okay. So I'm going to click Buy Active Layer. Yes, I would like to execute. And when you do it by the entire layer, you'll actually get this pop-up in the left-hand corner. All right, it looks like our task is now complete. You will see that it actually started to creep into some of those other areas that it had a little more difficulty in the first execution. So you can always run your tool in the same area over and over if you wanted to test those parameters a little bit better, but we still missed some of these sections. Now, in this step, this is basically the same as what you would get from your AI. Now, with any classification method, there is always need for manual inspection and manual cleanup, okay? There will always need some human intervention. So we're actually going to go ahead and complete our results from the AI so we can look to see the difference in the cleanup needed between those, and we can go from there. So I'm going to go into my job manager, click in this button up here at the top. Here are my AI results. I'm going to complete those and add them to my table of contents. Okay. There we go. So let me change this display so we can actually see the difference in our ground. So I'm going to do a ground system. And let's do a 10. So it's a little easier for us to see those results. You will see this one little peak here. That's because it's got a point on top of that building. Because remember, with our AI, we are not providing it any seeds. We're not providing it any other input. But it's also still classifying those noise points for us, and it's classifying and it is smoothing our data set. So first, I want to see the number of points it got for its noise. So I'm going to go to classification and click scan, because I do want to see the difference in these noise versus the ones we did. So this one only got about 700 noise points, whereas our other classification got about 3,000 total. So there was a drastic difference between those because we were able to tell it parameters on what to look for versus it using some defaults and auto detection in the one with the AI. So there is some differences. That's okay. We're also just going to go look at our building rooftop because I want to see how many points it got on top of this. So I'm going to look at this one and I'm forcing 100% so you can actually see where I got this big block. So it looks like it did get several points on top. So that's where you would need to go manually inspect that. You need to get those out of there because they don't represent your ground surface, right? So like we did before, we could either do the profile view option, or we could do the cleanup manual. So that's what I'm going to do to go ahead and remove these points on top of my roof. All right, so that's okay. We're going to click OK. Should be fine now. It corrected that for me. Okay, so I'm now just going to draw a box around this. I don't know why it's selecting all those extra points over there. Space bar, and it should work to remove those. And it changed something. So pause. I may have to redo that. I am suspicious. There we go. Okay. So I did click spacebar and it was able to remove those points. So we don't have that building rooftop included in our ground surface anymore. But we're now just going to compare those results with the other. So I'm actually going to toggle to my smooth ground again. Okay. So we're going to zoom in right here. So we do have these two steep slopes. I'm going to change this to my ground system so that now both of them are using the exact same display method. I'm going to go back to our AI to see if it performed better along those edges. So it did manage to get a lot more of those points along this edge versus our other one. Now, we could always try to force 100% since we're only looking at a small section. It might be able to actually do it. But you may notice right here, instead of it saying 100%, it says TOVF. That means you just have too many points for it to display for your machine. Okay, so that amount can vary. But also, like if you have it forcing 100% and it gets to this point, you probably do not want to scroll, pan, or anything like that because it will significantly slow down your machine. So you will want to turn that off before you do any of that. Okay, so just to kind of check out what that looks like with our all systems, we can still see it did miss a few of the points around here, but it did a significantly better job, including along our curb. So if we look over here at our curb, it looks like most of it is colorized in orange, versus if we look at our smoothed, look at these all points. We had a lot of the top of the curb that did not get classified. Okay, so there's some differences there. Now remember I said we can use that cleanup tool to help us address this. So I'm going to really focus on this one area. So also if I look underneath my canopy, I can see that it's gray, but if I look at my ground system, and this is just for display purposes, I'm going to change it to a point, you can actually see all those black spots, okay? So that's where this was not able to find any points for our ground. So just to compare that with our AI, we're going to do the exact same display, ground and points. So we can see they both struggled in this same area, okay? It was having a really hard time finding any points underneath this canopy. Now, this ground cleanup tool I can use very easily in areas such as this one. So we're going to go back to our all points, go back to our 10, and I'm going to use this cleanup tool to help me around this ramp. Okay, so I'm going to do cleanup, I'm going to do the assisted, and remember I want to start at normal and then work my way up to make it do what I want it to do. So I'm going to do by polygon, and I'm just going to draw a big box around the spot that it struggled at. Whenever I have selected everything that I would like, I can double click and it will execute this task. We can see it running in the bottom left-hand corner. And you may see some points highlighted in yellow. Now, for your screens, they may come in blue, as blue. I actually changed the color of this temporary storage class that this tool makes use of to make it easier for viewing capabilities. So if you would like to do the same thing, you can go into your live view filter. And as I mentioned, this tool actually uses a temporary storage class for your ground classification. So if I scroll down, I'm looking for this ignored ground class. By default, this is going to be in blue, but especially for those of you that may be colorblind out there, it's a dark blue. It may be difficult to tell the difference between that and gray. So I changed mine to yellow so it would really pop out against everything else. Okay. All right, so it looks like normal did not do a very good job, and it classified something on top of my roof. So I don't want that there. I'm going to do the little remove tool. I want to get these out of there. Let's see if it'll actually do it. Yep, perfect. It removed them off my building roof. That's what I want it to do. I'm going to go back to my assisted, but I'm going to choose the aggressive option. I'm going to move up one level, and I'm going to run it by the exact same function over this slope. So I'm going to try to grab all of it, double click, and it will begin to execute, and we're going to see how this one performs. Okay. And you can see it slowly starts to creep in more and more as we move upward. Now, if this was a very flat area and I jumped up to aggressive, that might be a problem. But for example's sake, I am going to change it to extreme. And I'm going to grab a little bit of this building rooftop when I do this, so you can see what it looks like if you just immediately jump up to a much more powerful execution. So I'm going to grab just a big chunk like this, double click. Now you can see how much of my building it grabbed that time versus the first execution on normal. It did do a lot better on my slope. It's still struggling right here where it actually gets up to that edge and kind of falls off because it's like, oh, those are at very different elevations. I don't like that all that much. But it'll also start grabbing other objects. So we do want to keep in mind that's why we don't just immediately jump up, because it can end up over classifying, and then we'll have to do this whole step again where we go in and remove all these points. Does that make sense? Okay. Now, if I was satisfied with these results and I did want to commit them to my ground class, which means I actually want to move them into the ground group, I can go click Commit Edits. It will ask me to confirm I want to move them from the temporary class, which is class 20, to the ground class, which is class 2. In this case, the answer is yes. It will perform what's called a basic filter to move that classification over. That way they will be part of the actual ground group. Now, in the manual options, you can also manually select ground points too, so you don't have to just use the assisted. You can go in there and you can actually draw around wherever you want to select these, spacebar, and that way it'll grab all the points in the area that you have selected. Okay. Now, I mentioned earlier in our presentation, there is 2 different ground cleanup tasks. So there is this tool function, which is fully automated in either way that you try to execute it. But we actually have a PCT option as well that allows you to sweep underneath canopy and select points. So that's what I'm about to do. So before I get into that, I'm going to draw me a profile. So I'm going to get my little profile icon, turn off force 100%. I want to grab as much as I can underneath here, but instead of dragging and selecting, again, I'm going to right click, and I want this to stay nice and narrow. So I'm going to do 0.3, because remember, we're looking for the definition of our point cloud. We're not wanting to see a whole bunch of stuff smushed together, right? Now that I've done that, I'm going to go to my point tasks ribbon, into my PCT manager, and this time we are looking for the task labeled 007-TrueView-Ground Cleanup. 007-TrueView-Ground Cleanup. Okay. Now this one does have similar angular thresholds and the maximum distance like our perform iteration, so you could go in there and modify these in the same fashion as we did before. But for the sake of this exercise, I am going to leave them as defaults. Okay, I'm not going to change anything. Now, when you do that, you may notice that the only execution method for this is by polygon, and there is a reason for that. Okay, so what I'm going to do is, because I'm having trouble underneath this canopy, I want to select around that, and you'll notice that my profile actually follows me around, right? Now, once I've made my polygon, I can double click. Once again, it's letting me know that I have selected over 500,000 points That's okay. I'm going to click yes, but then it's not going to do anything. It's sitting here. It's waiting on us. So what it's waiting for is for you to manually go in and select ground points. And this is where you're able to get underneath that canopy. So I'm going to zoom in over here and I'm just going to click a random point that I know is ground, which will be right here. I'm going to come and hover over my profile view. And using the select key and my arrows, so I'm holding down the select key, I can actually rotate this underneath my canopy. Okay, so that's how I could penetrate underneath in those areas that I'm having a hard time classifying, and I could look for any points down here that I might want to select. So I can see there's one right here. Maybe I want to grab that one. If you have a hard time clicking it, it could be just because you're a little too far out. That's okay. You can also scroll through, but it looks like we weren't able to penetrate that canopy very well. So since this is hard for me to click on, instead of doing anything crazy trying to select those, I'm just going to come make my points bigger. It'll be a lot easier for me to see and for me to select. So I'm going to change that to a 4. Okay. So here's a point right there. Let's see if I can select it. Maybe not. Is that part of my screen? Yes, it is. Okay, sorry. Let's see here. See if we can find an area that it struggled in. So it looks like it actually did a pretty good job for the points that we have in here. So if I scroll back through, this big hole is because our canopy was so dense, we actually couldn't penetrate it. So it makes perfect sense why we have that hole. But if we continue to scroll through, so here's a little spot, looks like it didn't pick up, so I can drop a little point there. It'll actually show you where it is. You do have the ability to drag that up and down if you need to, but I'm just gonna leave it as is. I'm gonna keep scrolling through. Here's another little spot. It missed a point there. It missed some points here. I can hold shift and start toggling through again. So here's some more points that I think would be good ground points. Rotate through. Here's some more. So you can very meticulously go through here, and you don't have to select everything. You just need to give it an input for it to be able to identify these points once you're done. So I'm going to just swing through basically. There's some points. There's a point. There's a point. Continue to swing through there. Say that's another one. And you may have noticed too, so I want you to watch how I move my mouse here, but I want you to look up in my map view. You'll see this little dashed line right here. As I move, you can actually see where that falls, so you can make sure it's inside of your polygon to select. Okay. So like I said, I'm just going to grab a few more points and see if there's anything else under the canopy that I may have missed. I think for the most part, this did really good underneath here. But I can also select over here on my sloped edge. Okay, I can come back in here, I can zoom in on it, and I can just click points at random. Da, da, da. Looks like there's a spot that it missed. I'm going to grab some points on that. There we go. And then whenever I'm done, I'm just going to find somewhere that's just flat ground and double click. It will then begin to execute in the bottom left-hand corner. And it will basically use all of the points that we selected as new seed points to classify additional stuff underneath. So it did actually manage to crawl over here onto my edge a lot better. It still missed some points, but I didn't really go in there and meticulously select along this boundary. So that's okay, that's kind of expected. If we go back to our ground system, back to our points, again, that was so dense we couldn't get underneath it, but we don't have quite as many blank spaces as we did before. Okay. So that's really helpful for doing that. Does anyone have any questions on our cleanup options? Yes, no, maybe so. Now you may also notice here, I'm going to just start inspecting my building. So this is on my smoothed as well, so I didn't clear out the center. I do want you to take note of the fact that it looks like there's some points creeping in here. That's because actually during flight, our LiDAR was able to shine through our windows slightly. So these are technically noise points because they're inside of our building. We don't know if they're accurate, you know, so you may want to remove those as well. So a very quick way of doing that is just drawing basically a little square inside of this using the remove button. So I'm going to go to my remove, and I'm just going to try to draw like a big box all the way across. Just a big, big box. Oops. Oh, wait, no, this is the space bar. Space bar, that's fine. That way I don't have all of those stray points on the inside of my building. Because again, when it's hitting those windows, there is going to be some level of reflectivity to those. So those points are very unlikely to be accurate. Okay. All right. Now that that's done, we could imagine that this is a complete data set. Again, we could go and find, other areas that we missed. And another way to assess this versus going to manually select all those points or manually identify them is we can use our surface precision tool, which is what I'm about to do. So in here, I'm going to go into my input points filter, and I want it to only look at my ground surface this time. I don't want it to look at anything else. To turn all of those off, I'm going to use the toggle all off button found on the right-hand side. And then only enable the ground. Have I lost anybody? Because I hear a lot of clicking, but nobody's with me. I lost Brett. Where are you? Just keep going. Okay. All right. So we'll have our ground only selected. I'm going to click OK. I'm going to do my global setting because I want it to look at the entire area. You can change the name if you like. I'm just going to leave it as is. I still want to do that colorized group because I really want to be able to see all those colors pop. And I'm going to stick with that 2 centimeter threshold. Okay. We're going to click process. And this should highlight all the areas where our algorithm struggled. So I'm going to turn off the point cloud underneath. All right, so we can see we do have a lot of green here. So it did a really good job. But if I start to zoom in here, underneath my vegetation, these are a whole lot of areas I'd need to pay more attention to. So more than likely, this grabbed some vegetation and included that in our ground surface. So just for example's sake, I'm going to turn this on, and I'm going to draw a 3D box around this. We're going to go to classification, turn that off. Let's see, top down. It might be struggling to display everything. Give me just a moment, guys. There we are. Yeah, it was putting us into the point cloud. So you'll see there are some noise down there. I want to turn that off, so I'm only looking at my ground. There we are. Now, if I start looking at that, you can see how it has all these little peaks, all these little ridges, those little fuzzy things. That's more than likely vegetation that was picked up in our ground surface. So in this case, our algorithm did a fantastic job of highlighting where all of this was. Okay, so now I didn't have to scroll through my entire forest to identify those points. This tool did it for me. Okay. Now that same thing, we're going to look for any other red spots and check that out. It is right around our building, right where we were struggling to do that classification. So it is able to highlight all of those spots for us. As you can see, there's several out here in our vegetation, things like that. So we don't have to, go through and slowly scroll through the entire thing. We can let this do it for us. Okay. Same thing here. This is actually a little object out in front of our building that may have accidentally got included in the classification. Again, it's able to determine that. It does not meet our 2 centimeter threshold because it does have those extra points in there. So it's able to highlight that and say, this is out of the threshold. Okay. So this is a fantastic tool for assessing the quality of your classification. Does anyone have any questions on the results we're reviewing? Yes, no, maybe so. When there's silence, I assume you're just completely lost. That's what I assume. Okay. Now that we've done that and we have our ground surface done, we can begin to do some of our additional deliverables. So for example, some people may just want the ground class and they may be done. For some people, they may want to extract a thinned data set to make it a smaller file size, to maybe either share with someone over Dropbox or upload to the cloud or what have you. So the way you could thin your data set, there's actually two different methods. If you're okay with the randomized point cloud, so LiDAR is inherently random in the way it's collected, we can just do the thinning PCT. So that's going to be under your point tasks. In my PCT manager, I'm going to look for the task labeled 009-TrueView-ground. Hold up, we're going to redo that. We're looking for the one labeled 009-TrueView-ground thinning. Okay, ground thinning is the one we're looking for. Now this is another classified by statistic, similar to our create seed surface. So we're going to take a look at that. Under our inputs, it's only going to be looking at our ground, so it's going to be ignoring everything else. It's going to look for the median point, the statistical median, and it's going to look at a 1 meter by 1 meter grid. So in 1 meter by 1 meter, it's only going to classify a single point. You can also specify your destination class. In this case, it is using group 8. So I'm just going to click OK here, OK again, and I'm going to run it over my entire active LAS layer.
What was your cell size?
1. Mm-hmm. All right, so it looks like it only took a few minutes. So now to actually look at what that did, in my live view filter, I'm going to turn off ground and I'm going to turn on my reserved class. Okay. Minimize that, force 100%. Now this red color may be a little hard on your eyes, so you could always go in there and change it, but this is going to be a significantly smaller file size than what we previously had. So if I go into my live view filter just to compare these densities, I'm going to click scan, and you'll see my ground class has over 14 million points, but my thin ground only has about 46,000. So that's significantly less points. So if I wanted only this to be included in a file to provide to someone, we're going to go to our project ribbon. We're going to go to the export wizard. Now I am going to export points. If you wanted to, for some users, they may want this in a shape file, or they may want it as a AutoCAD DXF. So you do have a couple of options on what you can choose for your file format. I'm going to leave mine as LAS. Under my input points filter, we're going to toggle all off and only choose that reserved class. Okay. On my next page, I'm going to leave this as default. On my final page, I do need to specify my output location. So under my project, I'm just going to create an output folder. Like I said, I need to capitalize outputs in here, and this will just be thinned ground. Okay, that's all I'm doing. It's typing in a name. Once I click save, you will see the finish button has become available for me to click. It will execute, and I now have a brand new LAS dataset. Okay, that will be a significantly smaller size than my original. Okay, so that was our first executable. The next one we're going to do is we're actually going to create a DEM, and I'm going to show you how to create a regularized or standardized LAS file. So that means where you want it to be in a strict format. So we start off by creating a DEM. So again, we're going to go into our export wizard. But this time for your surface type, I want you to choose surface. Now for this, in my input points, I actually want to use my ground class because I want it to take the entire ground into consideration for this DEM. So I'm just going to have both of these options checked so it can look at all the elevations and it can do the interpolation itself. So I'm going to click OK. These are your different surface methods, but for this one, we do want to stick with the 10 method. And I want to pick some small cell size. So our thinned ground before, we did a 1 meter by 1 meter. I'm going to do that same thing here, but when I toggle between the two, you'll notice they are completely different. So I'm going to click 1. My export format is going to be a GeoTIFF. Okay. Next page, we're going to leave it as the basic filter or a basic extent. So that means it's going to look at the entire point cloud. That's what we wanted to do. On our final page, we got to specify that output name. So in my outputs, this is just going to be my ground 1 meter. Okay. It will add a little extension onto the end of whatever type of task I'm running. So since this is a DEM or an elevation task, it will do underscore ELEV for elevation. So I don't have to enter in DEM here. So I'm just going to click save and finish. All right. Here's our new DEM. Now, to create that regularized point cloud, the one that's in a strict grid format, I'm going to go into my Add Files dialog, and I'm going to click DEM to LAS. So it's actually going to take that DEM that I created and convert it into a LAS format. Okay. So let's go find it in our folder. So I'm going to go into my outputs. Here we are. Here's my ground 1 meter DEM. So I'm going to select this, click open. And since I know that this was ground only, I can actually specify the destination class because I know these are all ground points. So I wanted to go ahead and classify these as ground for me when it creates this new LAS layer. So I'm going to click OK. Now I do want you to take note that it is doing that project path variable again. It does it by default. So that way it'll create a folder inside of your project called DEM to LAS, so you can always locate this one later on. Okay. So I'm going to click OK here. It will generate that new LAS. And now I'm actually going to zoom in and toggle between the thinned LAS and the DEM LAS and let you see the difference. So let me turn off this right here. Don't want that one either. So we're going to zoom in on a random spot. Okay, right here. So you can see all my points are in a very strict grid environment. If I toggle to my thinned ground, you can see how sporadic it is. Now, because it was also interpolating for my DEM, not only did it structure these in a strict grid, it also interpolated across my buildings. So it made it a flat area as well. So if I change over to a 10, we can actually compare these here. So this is where it was interpolating across that surface. I change to my thin ground, make this one a 10 again. It's doing that same thing, but we are missing some of these sections. So that was just from the ground class itself. But for the most part, these results look very similar, but one of them is going to be a lot more smooth and a lot more structured. But either way, we technically accomplished the same task in two different methods. Does anyone have any questions there? No questions? Okay. All right. Well, now that we have thinned our ground and we have generated those, the next thing we can do is we can actually generate some contours. Now you can either do that off your original LAS datasets, so if you wanted to use that, or you could use one of your thin datasets if you wanted to be a little more smooth. So for that, I'm going to click on my thinned ground, and we can actually view our contours before we ever export them. So just to get a general idea of what they look like. That can be done by clicking contour here and just enabling one. Now, whenever you do enable your contours, I don't recommend you really zoom in and out, especially if you have all of your points turned on. So if you're looking at vegetation and buildings and everything like that, it will slow it down while you try to view everything. So we only want to be looking at our ground, and we only really want to zoom in and out when we don't have a lot of data going on. So right now, if I start zooming in, I am going to do it very slowly so it doesn't catch on me, but you will notice here around this, there are some little tins and things like that that is catching and causing these contours over. So in this case, you may want to create a break line or something like that to remove these points. If I look at my smooth ground or smooth data set, do our contours again, you can see it's still drawing across those. It's still identifying some of these shapes, but it's actually able to get more points around our building. So it's doing a better job of not cutting through it quite as bad in some of these areas. So we can actually see that this is a little block versus it being some smudged line. So if I go back to it, you'll see it's kind of a crazy looking shape. Now remember, that's because it's only using a portion of our points from the original data set, right? Same if I switch to my DEM contour. Now it looks like it's kind of more following along, and you'll see these shapes aren't quite as sharp when they jump around. They're a little more blocky, and that's because it's more in a rigid format. So it's allowing for smoother contours across the surface. So that can be, you know, one of the deciding factors on how you want to generate your contours. Everybody with me? If you would like to export these contours, you can do that by going into your export wizard again. While you still have the surface method chosen, you'll enable your contour down here, and it will actually create a new tab for you to go and specify the settings. So I can actually turn off my elevation. I don't want a new DEM generated. I can go to my contours. I can change the intervals. I can change the output format to a shapefile, DXF, DGN, depending on my needs. I'm gonna leave it as a shapefile. You can also include the annotation if that was of interest to you. Okay. So I'm going to change these. I'm going to change this to 2, and we'll change the shortest to 25, something like that, just cutting this in half. And I still want to make sure it's only using my ground. Okay, so there's my ground, there's my reserved class. Okay. Next, we're going to let it look at the entire area again. Next, one more time. And this time it will be my ground. And I'm using my DEM, so I'll say ground gridded contour. Okay. Save. You can also put your interval in there if you wanted to, but I'm just going to stick with that for now. Click finish. Okay. And it's now created those, but to make this a little easier to see, I'm going to double click on it, and I'm going to increase these sizes just a touch. And now you can really see those pop out on my map. Now, because this area is still relatively flat, and because of the interval that I specified, it actually didn't pick up all this other smaller stuff. So I didn't pick up my building here, it didn't pick up this building. So in this case, this would actually be a very good one to use moving forward. All right, so now we've looked at that. We've done our contours. We've done our gridded ground, we've done a DEM, and we've generated our orthos. So for the sake of our exercises, we have finished our training today, and you have learned how to do everything in LP360. If anyone would like to see any additional workflows, please let me know. If you would like to store any of your outputs today in the cloud, so for example, if you were doing your own exercises, you could go to the cloud tab, and you could use this uploader here to push those up to the cloud as long as you have that collaborator license. Additionally, you could click this folders option here, and it would actually take you to your cloud to navigate through to see what you already have pushed up to your cloud at this time, so you could verify if your results have made it or not. And for those of you that may be looking for a new feature in LP360, remember on the support ribbon, we have the ability to request a feature. Please use this if you have anything you'd like to see in LP360. The more details you provide us, the better. That way we can make sure we replicate exactly what you want to see. And the more often we see a request, the higher priority it becomes, the more likely you'll see it in the next release. And with that, thank you guys so much for joining us, and have a wonderful day.